Reviewing our types of factoring today. Factoring we're going to be using a lot throughout the rest of the year, so we're going to have to do lots of practice with it. So for our three different types of factoring, who remembers them? GCF is one of them. Oh, helps if I pick a pen. So GCF, that's our first type. Dots is our second one. And then what's our last type? Trinomial. So then underneath each one, I have a few examples for us to go through. So for GCF, remember, you always want to look to see what is the largest number that goes into all of your terms that are there. With your variables, it's the lowest exponent that's present is your GCF. So if we take a look at example 1, I have a 6 and I have a 15. So what's the largest number that goes into both 6 and 15? Anna? 3. So I'm going to write my 3 here. If we look at our x's, we have an x to the third and an x to the second. So as I said, the lowest exponent is your GCF. So we're going to use x to the second. And then what would be our lowest exponent on our y's? 2. So y to the second would also be it. And then I put one set of parentheses after it. Your GCF always goes out in front, and then you have one set of parentheses. Who remembers how we get the stuff that goes in the parentheses? Yeah, we got to do some division, and what's left goes inside the parentheses. So you've got to divide both of these by your GCF. Now, you don't actually have to show that division step. Some of you can do it in your head, and that's perfectly fine. If you need to do that step, go right ahead and do it. So 6 divided by 3 gives us a 2. Now we're back to our exponent rules. X to the third divided by x squared. I subtract my exponents, so I get x to the first. And then my y's, since they are the same exact exponent, they just cancel each other out. So 2x is our first term. And then minus 15 divided by 3 gives us a 5. This time our x's cancel because they are the same exponent, and then we get y to the third. So there's our final answer. That's our factoring using GCF. So what you have to keep in mind is out here, the 3x squared, y squared, that is one of your factors. Inside parentheses, that's your other factor. So we have 2 factors for that binomial up there. Our second one, 36x squared minus 25y to the fourth. This is our dots problem. So if you remember with dots, you have to set up 2 sets of parentheses. Within the parentheses, you're going to have one that's a plus, the other one is a minus. So then we have to look at our first term. What multiplies to give us 36x squared? Yep. We got the 6 and the 6 for the 36, and then the x for the x squared. So our first terms in our parentheses are 6x. If you can't figure that out in your head, the other way you can do it is take the square root of 36x squared. The square root of that is 6x, so that's your first term. How about for 25y to the fourth? Anna? Perfect. 5 gives us the 25, and then y to the fourth would separate into y squares. You divide your exponents in half. And that's our factoring with dots. You have to keep in mind in your final answer, your first terms are the same, your second terms are the same. The only thing that's different is one's positive and the other one is negative. And again, that order doesn't matter. You can put the minus first and the plus second. And then our trinomial method, I like to refer to it as the guess and check method a lot of times, because really that's all you're doing. Is you are taking a guess as to what the right answer is, and then you have to kind of check in your head to see if you were actually right. So our first one, we have x squared minus 8x minus 20. So again, we start with our first term. To get x squared, we would have x and x. Next, you want to look at the sign in front of your third term. So we want to look at that minus in front of our 20. That tells us what kind of signs we're going to have when we factor. So since that's a subtraction, what are our signs going to be? The same or different? Different. Good. So we're going to have one subtraction, one plus in my parentheses. So now we have to look at 20. What multiplies to give us 20? 2 and 10. Now I'm looking to get a negative 8 in the middle. So if I put the 10 with the minus sign, the 2 with the plus sign, what I'm doing in my head, and you don't have to write this on your paper, but in my head, I'm doing a little smile, and I'm multiplying those together. That gives me negative 10. And then I multiply these outside ones. I call that my big smile. That gives me a 2x. If I combine these, negative 10x plus 2x, that's how we get our negative 8x, remember. Again, you don't have to write the little smile, big smile. That's a step we want you to start doing up in your head because it takes up a lot of space. And with our factoring, it's going to be like in the middle of a problem. So your little smile, big smile will get in the way of the rest of your work. So let's take a look at the next one here. Set up your 2 sets of parentheses. Our first term is an x squared. So we're going to put an x and an x there, because x times x gives us x squared. If I look at my last sign here, I have a plus sign in front of my 16y squared. So that tells us our signs are going to be the same. A plus sign at the end means they're the same. You then look to the sign in front of it. That tells me they're both subtraction. If this sign in front of the 10 was positive, they would have both been positive. So now we have to figure out what multiplies to give us 16y squared. Nico? 8 and 2. And because we have the y squared, we need to put a y with them. So 8y and 2y. So again, in my head, I'm doing my little smile. That would give me a negative 8xy. And then I'm doing a big smile. When I multiply these two, I get a negative 2xy. And when I add those together, there's my negative 10xy. And then our last one down here, this one's a little trickier because there's a number in front of our x squared term. We have a 2 in front of there. The only way to get a 2 is 2 times 1. So we would have a 2x and a 1x. But again, we don't have to write that 1 out in front of it. What will our signs be this time? Same or different? Different. Good. And then how do we multiply to get 7? 1 and 7. We really don't have many options with that one. So then again, in my head, I'm doing my little smile. 1 times x, that gives me a 1x. 2x times negative 7, that gives me a negative 14. So when I combine 1x and negative 14x, do I get positive 13? No, what do I get? Negative 13. So I'm close. What I'm going to do is I'm just going to change my signs. So I'll make this one the negative, that one the positive. So now I just check again. Little smile gives me negative 1x. Big smile gives me positive 14. 14 minus 1, that's how we get our 13x for our middle term. So we did that one correctly now. So going one step further with our GCF, sometimes our GCF is a binomial. Like if we look here, well, that's a really big highlighter. I didn't want it to be that big. There we go. Let's shrink it down a little bit. If you look inside those parentheses, they both have a 2x plus 1. That's our GCF this time. So when I factor this out, just like we did before, I put my GCF first. The only thing is my GCF's a binomial, so I got to put it in parentheses. So I still put my GCF first. If I take 2x plus 1 away from here, what's left? We're left with that x. And if I take it away from here, I'm left with my plus 7. So this one would factor into 2x plus 1 times x plus 7. What's our GCF for choice B? Very good, x minus 2. So I put my GCF first. Inside my other parenthesis would be my 5x and then my minus 4. Now C and D, of course, a lot trickier than the first one. So what is our GCF? Very good, x minus 7. So I'm going to put my x minus 7 first. So now, though, I'm left with x plus 5 from the first one. And what's left in the second group here? X plus 1. These two have to be added together, because up here I did my x plus my 7, my x one here plus my 7 one here. So what's left goes here, x plus 5 plus my x plus 1. Now, do you think we could actually leave our answer like this? No, they won't let us do that. So we just have to combine our like terms in there. So I have x plus x gives me a 2x. 5 plus 1 gives me a 6. So that would be our final answer. Then D is going to happen the same exact way. What's our GCF? Very good, x plus 4. So then from the first grouping, we're left with a 2x plus 8. Oh, this one wouldn't be plus this time. This one would be minus. Second grouping, we're left with the x minus 2. So then again, we just have to combine stuff in this last grouping here. So x plus 4. So then we have 2x minus 1x. So that gives me an x. And then 8 minus negative 2 would give us a 10. Remember, you minus a negative turns positive, so it's really 8 plus 2. X plus 10. So difference of perfect squares, we went over this up on the top. Exponents, you just divide it by 2 when you put it in your parentheses. First terms are the same, second terms are the same. It's your plus and your minus is the only difference with your difference of two perfect squares. Again, key things here are difference. A lot of times you will see problems that look like it's going to be dots, but it's got a plus sign in the middle. So it's not. Difference means it's got to be a subtraction problem. Other thing is they have to be perfect squares. Again, otherwise it's not going to work. So if we take a look at our examples here, I'm going to set up my parentheses. So for 4x squared, I know to get me a 4, I got to do 2 times 2. To get me x squared, it's going to be just x and x. So I have 2x plus and then a 2x minus. And then what multiplies to give us 25? 5 and 5. And then again, just divide your exponent in half. So it would be 5y to the third, 5y to the third. We'll add that little rule up here. Divide exponents by 2. Now for example 2, I have a lot of kids who are like, oh my god, there's a fraction, I can't do this. It's okay. Take the fraction and separate it. What multiplies to give us 36? 6 and 6. What multiplies to give us 81? 9 and 9. So it would be 6 over 9 and 6 over 9. So then again, we take our exponent, so it would be a to the first, b to the fifth. So 6 over 9, ab to the fifth are our first terms. Yes, ma'am? Yeah, you can put the 1 there. Totally. So then for our second terms, what multiplies to give us 49? 7. And that would be y to the what? 6 and z to the, so it would be 7y 6 z 2. 7y 6 z 2. Now third one, that's still an example of your dots problems. This is a perfect square because it's got that exponent on there, and then 9 is a perfect square. So when we factor these, we would have a plus 2 and then a plus 2 are your first terms. Because remember, if anything's squared, that means you just write it twice. And we got our plus minus, and then what multiplies to give us 9? 3 and 3. And again, of course, they won't let us leave it like that. You just have to simplify. So the 2 plus 3 makes this term a plus 5. 2 minus 3 makes that term a minus 1. Then going over our trinomials, again, you want to look at your first terms, and then we look at our last term that helps us pick our signs and figure out our factors. So, this up here is going to start out as x minus and an x minus, because x squared is x times x. My 21 is positive, so that told me my signs were going to be the same. I looked to the sign in front of it. That told me they were both going to be negative. What multiplies to give us 21? 3 and 7. Do they add to give us 10? Sure do. So that's how that one factors. Again, same rules apply when you get into the higher exponents. So for number 1, we've got x to the 4th. So we would just divide the 4 by 2. So it's x squared and x squared. What will our signs be? Same or different? Different. Very good. Now we just have to think of, okay, what multiplies to give us 40, but then when I do little smile, big smile, it's going to give me a 3. 5 and 8. So, okay, we put the 8 here and the 5 here. My little smile is positive 8x. Big smile is negative 5x squared. Combine those and you get your 3x squared. So there we go. We got our middle term. So what I'm going to do is I'm going to give you just a couple minutes. I want to see if you can try 2 and 3. And then I got the third one up there. You should have had x squared y to the third plus 5, x squared y to the third minus 9. The only thing that matters is that subtraction sign has to be with the 9. So if you have that in the first parenthesis, that's fine. And your plus 5 is in the second one. All good to go. Now it does get just a little trickier when your lead coefficient is not a 1. So when you have another number in front of your x squared, it does make your factoring a little trickier because you have more options at that point in time. So for the first one here, number 7, with the 4x squared, we could separate it into 4x and 1x, or give you 2x and 2x. Really, it's just, you got to pick one and try it. If it doesn't work, then you go back and try the other one. So I'm going to start trying with 2x and 2x. We'll see if this one works. Our signs will be different. So a plus and a minus. And then what multiplies to give us 3? We don't have many options. 1 and 3. So if I do my little smile, I have a 6x minus a 2x for my big smile. That gives me a 4x. I'm nowhere near the 11x that I need. So that tells me probably I need to change my 2 and my 2. So I'm going to try 4x and 1x. So now for a little smile, I have a 3x. And then my big smile is a negative 4x. Again, that doesn't get me there, so maybe I need to switch my 3 and my 1. So now my little smile is a 1x and negative 12x. So that would give me negative 11. I'm a lot closer. I got the 11 this time. Now all I have to do is change my signs. So now I have my 1x, my negative 1x, my positive 12x. I get my 11x that I needed. So see, that one took us 4 tries. Sometimes it happens. Sometimes you can see it right away and it doesn't take you very many tries at all. Now number 8, that one's nice because you don't have a lot of options for 2x squared. It's 2x and 1x. That's all you can do. And then our signs are going to be the same because we have a plus 3. They're both positive because you look at the sign before, that one's a plus. And then again, we don't have many options when we're multiplying for a 3. It's 1 times 3. So then I check my little smile here with the way I have it set up. I have a 3x. Big smile gives me a 2x. So I add those together and I get a 5x. So 9, do I have many choices for 5x squared? No, that's good. So it's going to be 5x and 1x. My signs are different. One's positive, one's negative. Again, I don't have many choices for a 7. It's 1 times 7. So then I check to see if I got it in the right place. So 1 times 1 gives me 1x, negative 35x. So I definitely do not have them in the right place. Bless you. So that one works out to give you your negative 2 in the middle. So we get a little smile of negative 7, big smile of positive 5. That gives you the negative 2. Let's have you try these last 3 on your own. Let's take a look at these. It looks like some of you are kind of stuck a little bit at some points there. So I went through and I filled in the first terms. All of these were a little easier because 3x squared, the only way you can break that up is 3x and x. 2x squared, you can only break that up using 2x and x. All of these our signs were different because we have a subtraction sign at the end of every single one of them. So looking at number 10, our next thing we need to be thinking about is what multiplies to give us 6. So to get a 6, you got 1 and 6 or 3 and 2. Those are our 2 options here. Because I want to get to a 7, I'm leaning towards the 3 and 2 option. So I put my 2 there, my 3 there. Remember, to get the 7, you should be thinking little smile is a 2x. Actually, it's a negative 2x. Big smile is a 9x. When I combine those, that's my 7x. So that one's done now. Number 11, what do we multiply to get us 21? 7 and 3. And I did see some people had this one. Minus 7 plus 3. Because again, little smile here would then give us a negative 7x. Big smile would be a 6x. Combine those, there's your negative 1x. And then our last one, 32, 8 and 4. So I put my 8 there. My little smile would give me a positive 8x. I'd have a negative 12x from my big smile. Combining those gives me my negative 4x in the middle. So again, you just got to keep playing with it, keep doing trial and error, doing that little check in your head. Now with these last three, you factor the same exact way. It's just you cannot change the order. You have to keep that x squared term at the end. So I know that goes against all of our standard form rules that we tell you, but as far as factoring goes, it changes the answer in the long run in other problems we're going to be doing this in. So you want to leave that x squared term at the end. So in that case, I just start filling in from the back then. Since x squared comes last, that means it needs to be in the second spot in our parentheses when we factor. It's a negative x squared, so that means my signs need to be different. So I put a plus and a minus. And we still play around with the numbers to figure out where they need to go. So what multiplies to give us a 36, but when I combine them could give me a 5. 9 and 4. So we still have to check to make sure it's in the right spot because I want to get a negative 5. So my little smile would give me a positive 4x. Big smile would give me a negative 9x. So yes, I would still get my negative 5x. Number 20, same thing. I have a negative x squared at the end. So that means one's plus x, the other one's going to be minus x. So now what multiplies to give us 14? 2 and 7s. Let's try this. So my little smile would be a negative 7x. Big smile is a 2x. Oh, close. That would give me a negative 5. So I have the right number. I just need to change my signs. So now my little smile is positive 7. Big smile would be negative 2. That would give me my positive 5x. So then our last one, signs would be the same. They'd both be negative, so we would have a minus a and a minus a. So we're looking for what multiplies to 72 but combines to give us 22. $18 and 4. 18 times 4 is 72, and then 18 plus 4 would give us our 22.